In this session, I would like to talk about how to represent numbers. Generally, as a human being, we are comfortable with our 10 fingers. That's why decimal system has been introduced, and we represent our numbers using decimal system. Similarly, we have binary, we have ternary, of course, we have hexadecimal, we have octal. Correct. So these are all the wide variety of formats we have. But question number one: what kind of format is comfortable for your computer? So computers are generally designed such a way that they can understand positive and negative signals. Otherwise, I can say two signals. So that's why. So numbers also to be represented in binary. Any data, not only numbers, should be represented in a binary format. Even characters or any information we are going to represent using, even instructions of the computer also can be represented. Otherwise, should be represented in a binary format. Okay, that is one thing you should understand. Second thing, so how to represent integers, how to represent real numbers, all these things we have to study. So before going to that real implementations of that numbers, representations, that means what kind of representation is comfortable for your computer, that we will see at the end. Before that, we will see general representations like what is binary, what is hexadecimal, what is octal. After that, we end up with the representations which we use for representing the numbers in computer. Okay, so let's begin with general representations first. Number representations. Example, you have a number. Okay, let's say that is a positive numbers. Okay, unsigned numbers. When you have unsigned number, how to represent it in decimal? Very simple. Example, you have a number 23, we write 23. Okay, and we say base 10, and this is exactly equivalent to saying 10 to the power of 1 into 2 first digit plus 10 to the power of 0 into 3. Okay, so both are same. Similarly, we can write a binary format. Correct. Example, let's say 0 0 1 0 0 1, let's say, and base 2. This is a binary format, right? So that is, so what is the equivalent decimal value for that? If you want to know the conversion, so we have to give the weightages. Okay, so every number system is a weighted model: 2 power 0, 2 power 1, 2 square, 2 cube. If you give weights like this, and if you multiply 2 cube into 1 plus 2 square into 0, you are going to get the decimal version of this binary format: 2 to the power of 1 into 0 plus 2 to the power of 0 into 1. Then it would be 8 plus 0 plus 0 plus 1, 8 plus 1, 9. In that way, we can convert binary to decimal. Okay, similarly, we can represent your numbers in octal also. Example, in octal we will have digits 0 to 7. Okay, example, if you have a digit like 777 in octal, what does it mean? How to convert it into decimal? Same idea. 8 to the power of 2, this is the 8 squares. I can say this position represents 8 square. So 8 square into 7 plus 8 into 7 plus 8 power 0 into 7 is the conversion. This will be decimal value. It would be 64 into 7, whatever it is, plus 56 plus 7. In that way, we can convert any I can say any representation to decimal, right? Similarly, you can have hexadecimal like this: a b c base 16 is equivalent to dash in 10. So the formula is 16 square into a plus 16 into b plus 16 power 0 into c, right? We know that 256 into what is a? A is nothing but what is the value of a? A value 10, right? 256 into 10 plus 16 into b value 11 plus 16 power 0 1 into c digit means 12. So in that way, it would be 256 2560 plus something 176 here plus 12. We have to simplify it. In that way, we can convert from other base to decimal. Now we will see how to convert from decimal to binary, decimal to hexadecimal, decimal to octal. Okay, let us see how to convert decimal to binary. Okay, 256 base 10, I would like to convert to base 2, 239 to base 8, to 225 to base 16. Very simple. So for that, take 254 and divide by 2 and identify the remainder every time. Okay, so 2 127 is 254, remainder 0. Then again you repeat this process, divide the remaining number with 2, then you get 263 is 126, remainder 1. In that way, we have to identify remainders first. So 231 is 62, remainder 1, 215 is 30, remainder 1, 27 is 14, remainder 1, 2 3 is a 6, remainder 1, 2 1 is a 2, remainder 1, 2 0 is a 0, so this is the last point, remainder 1. In that way, so we end up with this point. So after that, nothing. If you continue also, there will be an infinite loop. 2 zeros are 0, remainder 0. 2 zeros are 0, remainder 0. That's why. So this is unnecessary. So after that, we have to write the numbers from top, bottom to top. So it would be 1, 1, 1, 1, 1, 3 plus 3, 6, 7 ones, followed by 0. This is binary. So if you have doubt, then you can convert this back to decimal and we can check it out. Let's try that. So we know that the weightages are, how to convert it into decimal. For that we have to give the weightage for every position. 2 power 0, this is 2 power 1, this is 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7, right? 2 power 7 into 1, 128, plus 2 power 6, 64, 2 power 5, 32, plus 8, plus 4, plus 2. If you count it, it would be 192, 224, 232, 240, 242, 128 plus 64, 192, up to here 224, 224 plus 8, we have missed 16 also, right? So it would be 192, 224, 240, 248, 252, 254. Yes, so we got it back. So this conversion is right. So in that way we can convert decimal to binary. Let us see decimal to octal. The procedure is same. This time you have to divide the 239 with 8. Then collect all the reminders. 8 2 is 20, 8 2 is 16, then 7, 79, 8 9 is 72, remainder 7, 8 3 is 24, remainder 5, 8, sorry, here it is 8, 8 0 is 0, then remainder 3. It would be 3 5 7 base 8. If you have doubt, you can cross check. Base 8. So this weightage 8 square, 8 power 1, 8 power 0. 8 square into 3 plus 8 power 1 into 5 plus 8 power 0 into 7. That is what we did here also. The process is same. 64 3s are 192 plus 40 plus 7. 232 plus 7, 239. Perfectly right. In that way we can convert binary decimal to octal. Now we'll see decimal to hexadecimal. Let's take 225 and divide with 16. 16 1 is 16, 6 65, 16 4 is 64, remainder 1, 16 0 is 0, then base is 14, remainder is 14. So 14, to avoid the confusion, whether it is a single digit or two digits, because in hexadecimal we have 1 and 4 also. That's why the numbers are in hexadecimal are digits 0 1 2 3 up to 9. Then to avoid the confusion, so we use A rather than 1 0, okay? Then 11, 12, 13, 14, right, up to 15. So 14 is E. So it would be E comma 1, E1. In that way we can convert from decimal to hexadecimal, okay? Now we will see conversion between binary to octal, octal to binary. After that we'll see the conversion between binary to hexa, hexa to binary. Okay, let's say 110 0001 and 1. So how to convert this to octal we will see. This is binary. So the technique is very simple. From left side, for every 3 digits should be grouped like this. So you end up with like this. So 011 is 3, right? 000 0 and 11 you add 0. So 011 is 3. In that way 303 base 8 will be the octal conversion. Now if you want to cross check whether these two are equivalent or not, let us convert both of them to decimal. First of all, for this one it would be like this. How to convert, we know that, right? We have to give the weightages. It would be 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So 2 power 7, 128 into 1 plus 64 plus, so because remaining things are zeros, I am not writing. 2 power 1 into 1, 2 plus 2 power 0 into 1, 1. So it would be 192, 194, 195. Let us convert 303 into decimal. 8 square into 3 plus 8 power 0 into 3, correct? it would be 64 3 is a 192 plus 1 3 is a 3, 195. Yes, that's why this model works. Finally, we can convert binary to octal with this model. Similarly, we can convert binary to hexadecimal. We will see that. Example, you have 1001, 1100, something 101. How to convert this to hexadecimal we will see. From the left side, take 4 digits and group them. Sorry, you have 3, then take that as a group, because always we can imagine 10 here without losing the definition or without losing the meaning. So if I convert that to hexadecimal, it would be, so 0101, is it not a digit 5 in hexadecimal? Yes, so it would be 5. This is 1110, 842 are the weightages. See, focus on 1110. 2 power 0, 2 power 1, 2 square, 2 cube. 8 plus 2 square and 2 cube. 8 plus 4, 12, 12, 14, right? So 1110 is actually a hexadecimal digit now, 14. Convert the 0100 into separately into hexadecimal digit, that is nothing but 2 power 0, 2 power 1, 2 square, 4, right? But 14 we know that is nothing but E, correct? 4E5. In that way we can convert binary to hexadecimal. One more. 1101, 0111, 1010. Let's convert this group like this. 1, 2, 3. So take each group and convert that separately. So 1010 in hexadecimal, for that you should know the decimal value first of all. 2 power 0, 2 power 1, 2 square, 2 cube. This is 8, this is 4. 8 plus 4, 12. 12 in hexadecimal C. That is the way we have to convert. So this is now to be converted to one hexadecimal digit. It is 7. Correct? So then this one 1101. 8 plus 4, 12. 12 plus 1, 13. 13 is nothing but D. Correct? So in that way D7C. 10 is A, remember, 10 means A, 11 means B, 12 means C, 13 means D, in that way. So we can convert binary to hexadecimal. We will see now how to convert octal to hexadecimal and hexadecimal to octal. That will be the final one. Example, I have some hexadecimal value like A, B, C. How to convert this to octal? A, B, C, let's take it as 16. Sir, I don't know the procedure. Let's try to use the procedures whatever we have already. We can convert this to binary, but given a binary sequence, we can convert to octal easily, right? That's why let me do that first. Convert this to binary, that is easy. How to convert this ABC 16 to binary? I will tell you. Because did you remember the grouping? For every 4, for every binary 4 digits, we converted them to hexadecimal. In the same way, we do reverse engineering. What is A? A was A means 10, right? 1010. In that way, convert each digit to binary. B, 8 plus 2, B means 11. That means 1011. Next, C means 12, 1100. This is the binary format of this hexadecimal format. Let's cross check. Whenever you have this kind of thing, how to convert to hexadecimal? This one separate, this one separate, this one separate. If you do that, you get ABC back. That means for this one, if this is a hexadecimal, for this one, this will be the binary. So in that way, we can easily get binary representation for any hexadecimal. Blindly do one thing. Take every digit and convert that to binary pattern. Correct? C binary pattern, B binary pattern, A binary pattern. Then group into 333 so that you can get octal. Right? This is a way we can convert to octal. So 1004, 111, 7, 0102. Now these are all octal digits. 1015. So 5274 is octal. So base 16 is converted to base 2, base 2 is converted to base 8. If you want to cross check, if you want to know again, convert this back to hexadecimal. How to do, I will tell you. Given by octal, how to convert to hexadecimal. What you do is, first of all, convert to binary, then go convert into hexadecimal. That would be good. Okay. So when you convert it to binary, you get this back. When you convert it into hexadecimal, you get it back in that way. So binary to hexadecimal to binary, hexadecimal to octal, octal to hexadecimal, everything we can do. Okay.